Hello, everyone. Welcome to Wind Down Friday. Today, our guest is the CEO of Nova Semiconductor, Ahmad Ashrafzadeh. Hi, Ahmad. How are you? How's it going?
Hi, Mauricio. Thanks for having me. It's a pleasure speaking with you.
Thanks a lot. Thanks a lot
Good.
for coming on. Where are you located?
We're in San Jose. South San Jose is where our office is.
Mhm.
Beautiful sunny day and weather's been great. So
Wonderful. Good.
good time of the
So,
year.
yeah. So, Ahmad, you are the CEO of Nova Semiconductor, and you have a great experience, great career. So, let's start with my first questions. What inspired you to start your company, Nova Semiconductor, and focus in particular on revolutionizing battery management technology? We talked time ago, a couple of weeks ago, and I posted an article on powerelectronicsnews.com about your technology. So can you explain the key principles behind your approach and how it would differ from a
Sure.
traditional method?
Glad to dive into that. So most of my career has been in power management, and in fact, I built quite a few voltage regulators at various companies. A lot of them at Maxim, where I spent a good part of my career. So battery management was kind of distant from me. It was not something I'd been doing for a while until not too long ago, where I had to pick a battery pack to power an audio unit. The interesting part of that was when I reached out to the vendors and I started digging into the details. It was very clear that most of these battery packs didn't have balancing function. And that came as a surprise. And so when I brought that up with the vendors, it was very clear that the cost was prohibitive at the time. This is about maybe 5 years ago, 6 years ago. And it was a surprise to me because the voltage regulator space was so commoditized and had been super crowded with many players, and the prices had gone down. So it was kind of surprising and interesting why battery management had not followed that path. And that intrigued me to look into the details and find out why is that. So again, this was kind of an introduction to battery management, and I realized the accuracy required to do battery management was off the chart, if you will. In all the years that I did voltage regulators, most of the voltage regulators were 1% accurate. And that was, acceptable and good enough and not too difficult to achieve. When I did the IMVP7, we suddenly had to go down to 0.5% accuracy, and that was a challenge. It was quite difficult to get there. Now, to go from that to 0.1% or 0.01% is a tall order, and it takes a completely different approach, if you will, to achieve that kind of accuracy. And that became a problem to solve, and I'm always been interested in solving problems. So just playing with ideas and having some background in digitally assisted analog. Over a couple of parts, I did the first PM bus chip that used that, and I had done some other patents regarding the digitally assisted analog. That came to mind, and I basically played with the idea and came up with a scheme that I was able to quickly prototype and prove the concept. And digitally assisted analog is essentially not relying so much on analog accuracy, but take the analog as it is and try to interpolate and do correction around the existing analog. Now, the analog is not the starting point basic analog. It's a usually special type of analog that you build specifically for the scheme. So it's a system that combines, special analog with a certain algorithm that you implement, say, in microcontroller, and together they can do magic. And so the dependency on analog is reduced, and that frees up quite a bit. Your die size gets smaller, your test time becomes negligible, the part can essentially test itself, and there's a lot of good that comes from it. Your dependency on temperature coefficients go away. So it's all good when it can be done. And interestingly, every implementation of digitally assisted analog is different from another. So each one is unique and novel, if you will, and what we found and implemented is one of those.
Great, great. So, Hamad, your career has seen design, engineering, marketing, leadership roles. So, a huge and wide career. What are some key lessons that you have learned during that period that are important, have been important in your journey as a technology entrepreneur? So, what also advice in this case would you offer based on your experiences to young people?
So innovation has always been the cornerstone of my life, and it's been something I strive to do. You know, it's always good to augment what we do and do it better. Sometimes you can measurably make a difference, and sometimes it's a small increment. So to do that, you really need to have an open mind and not accept status quo. In fact, status quo is pretty much usually an opportunity. You know, when I see a status quo, I see that as an opportunity to take that challenge and do something that hasn't been done. And you have to, you know, think out of the box. You don't settle for what's been done and tried or worked or didn't work. You basically have to take a step back and look at the whole picture. And that's usually something you have to do, which is, you know, be able to zoom in and also zoom out. You know, if you zoom in all the time, you lose picture of why you're doing something and you get lost in details, right? So it's important to occasionally zoom back, zoom out, if you will, and look at the big picture. See, what are you really trying to achieve? You know, what is the goal and how your small detail is changing the big picture. And that the ability to zoom in and out is quite important to innovate and be able to, again, not get lost in detail, which unfortunately a lot of engineers do. They zoom in all the time and therefore they lose track of why they're doing what they're doing. So, so that's an important factor that is enabler.
Thank you. Great. So, job, career, shifting gears to your hobbies. So last time you mentioned during our meeting, chatting, growing grapes and making wine. So maybe this is perfect, Wine Down Friday. So how did you get into winemaking? So give us more about your process. This is also engineering process.
It really is. So I have a large land where I live, and I always loved the look of, you know, grape wines, and that was really the driving factor. It wasn't so much to make wine, and I mean, I like wine, but I'm not a wine lover. But just, you know, the look was really amazing and interesting for me to implement where I live, and so I took an acre and grew some grape. I think I went overboard. This became a lot more than what you need for personal use and too small for commercial. So it's kind of half in between and became a bit of a challenge to deal with. So once I had the grapes and it looks amazing, you know, I love looking at it every day. You have to do something with the grape, and I started, you know, learning how to make wine, and so it became a big hobby. Every year, you know, there are multiple intervals that you have to get engaged and do a lot of work to make this happen. And it's a challenge, but it's a nice challenge. So as a result, we end up with quite a bit of wine that we usually give away to friends and family and consume some less and less as we go. But that's how it is. So
Good. So, Hamad, I remember that you told me to play with electronics and building circuits at the age of 12. You started at 12 playing with electronics. So, are there any memorable projects or discoveries from that time? Nice moments, for example, that still resonate with you today, nowadays?
So yeah, I'm one of the fortunate ones that turned a hobby into a career. My brother was into this stuff, and that got me started, and tinkered with a lot of things. I used to get this magazine, electronics magazine, which was monthly, and it would suggest a bunch of circuits to build, and there was a lot of great articles, and that was an amazing introduction to this space, if you will. So I was very interested in amplifiers and transmitters. Those are the two circuits that I always found interesting, and built quite a few of those. The highlight of those years, which still amazes me, is I came across this article that talked about how to turn a tube amplifier into a transmitter. So it was basically, in those days, amplifiers were pretty much one circuit. There wasn't so many variations. So we had this old obsoleted tube radio that I was able to take out the amplifier, and I had the amplifier exactly as it was in the article. And you had to build a tank circuit around it with feedback, and that turned it into an oscillator, and it was an AM radio, right? Now I built a few transmitters already in a few milliwatts. This was supposed to be 10 watts. So I was really excited to finally get, the range that I was hoping to get and all that, even though it was illegal. I was, eager to test it out and see what happens. So when I finished that, I turned it on and turned on my AM radio, and I could hear it, a few meters away. I was able to receive the signal. So I learned it was working, right? Now remember, this is like I was 14. I didn't really have any training or any, detailed information on any of this. So to my surprise, when I walked away a few more meters, I couldn't hear anything. Now I had an antenna about maybe 2 meters long, and it said, in the article said you had to have a long antenna, but I didn't know how long. So anyways, I was really amazed that 10 watt could only go a few meters, and it was amazing. And I was like, so how do I know? How do I know this is 10 watts? And I basically thought, well, if it's truly putting out 10 watts into this antenna, if I put a 12-volt bulb, like a car kind of light in series with this antenna, let's see if it lights up. And I did that, and it lit up. And I was so amazed that with one wire, it could light up, a light bulb. So in effect, I discovered standing wave, years before I knew what it was. And it was just a state of surprise and amazement that, I can do this with one wire, and didn't understand it until I went to college and learned about the standard ratios and the details of that. So that still amazes me that it all worked. And I thought of, putting this light bulb in series with the antenna, and the fact that it lit up, it was like magic back then. And it still amazes me every time I remember that.
Great. So Ahmad, we are in conclusion of this Wind Down Friday. My last one. So about last time you mentioned also several hobbies. So how do your personal interests, like enjoying the outdoors, for example, influence your work in the technology sector? So do you find, for example, hobbies inspire creativity, problem solving in your professional life, in your professional tasks?
So from early days, I had interest in playing the guitar and music in general, and that led me into have a lot of interest in amplifiers, and that basically fueled my interest and engagement in building amplifiers. And I think all of that kind of started building my career from early days, and it was never a question what I was going to do. So I think having passion about something that can lead you towards a goal and a career is a great start, and it can make you a much better whatever it is you're doing because you're passionate about it. So I think people should follow their passion and make sure what you do for a living is something you're passionate about, and that makes life a lot easier, and you enjoy the rest of your life doing what you do and enjoy that. So, having passion, I think, is quite important about your career and job and your profession. And I was, again, one of the lucky ones to be that.
Yes, good. So Ahmad, thanks a lot. Thanks a lot for joining us at Wind Down Friday. So I wish you a great weekend and see you next. Thank you.
Thank you. It's been a pleasure. Thanks, Mauricio.